So in statics, we're going to be dealing a lot with forces. And it's really, really important that forces are going to be treated in a very special manner. You may have heard the term scalar. What scalar means is scalar has basically a magnitude, a quantity. So like mass is a scalar quantity. It'll have a specific mass. There's not a direction associated with it. But force is a vector property. Or you can kind of term it as a first-rank tensor property. So force, we're going to indicate either, you can do an arrow. I tend to indicate it with a single hat because this indicates if there's one hat, that's first-rank tensor property. Stress, which we're going to talk about in our fourth lecture in this course, is a second-rank tensor property. And stiffness, C, is a fourth-rank tensor property. So we live in a three-dimensional world, so 3 to the 1 power, first-rank tensor, means that force will have 3 basically components. 3 to the second power is 9, and 3 to the fourth power is actually 81. So that's lots of equations, lots of components. But force will have 3 components if we're in 3 dimensions, so an x, y, and z component, but typically, again, we're working just in xy coordinates, so you may write out force as, again, into x and y coordinates, so a magnitude, which is fx, and fy, and then, again, their respective Cartesian coordinates, ijk, where, again, this x, y, z, just for this notation. So I indicates, again, the I direction, j direction, etc. So we're going to break down, again, our force here has both magnitude and some directionality. And we're going to break it into components. So specifically, this force component, we're going to project into an x direction because I can basically write out this plus this vector here. If I add my fx plus my fy, in the j and the I direction, it will give me f. So it's just equal to this. So we can break this down into components. So we're going to project it here. Now, if I'm projecting, if I look at this triangle here, if I look at this is my f, this is my angle, and if I want to solve for x, because this is my x component, right? So if I want to solve for x, or my f, we can actually just call it fx here. What will fx be? Well, what's cosine of theta? Cosine of theta equals what? Adjacent, which is fx, over hypotenuse, which is f. So we can write out here, fx equals f cosine theta. Similarly, for this component, which we can kind of just drag over here, this is my f sub y. So if I write sine of theta equals opposite fy over f. So fy is equal to sine of theta. So you can rewrite and resolve essentially those components, and we can write out that our f is equal to this and this. So this is basically resultant forces. So we are going, when you have essentially these forces, we're going to resolve them into their x and their y components. We're going to add all of them together in order to find what is the resultant force. So for example, if we have multiple forces. So let's take an example here and let's find what are my resultant forces. What are my resultant forces in x? What are my resultant forces in y? So we're going to do that in the next video. So let's go ahead and do that then. See you next video. Thanks. Bye.